Hi, I am demonstrating our project 80% demo video. So we have currently implemented um, all the four algorithms. They are SVM, KNN, LR, and the decision tree. Um, we have implemented in CPU, mobile CPU, backend, and through multi-threading, and also in GPU. So the work that is remaining from our side is report and finishing touches with the UI that we will account in 20% of the remaining project. So I'm demonstrating. So with this we can choose any algorithms: SVM, KNN, LR, DT. So I'm choosing SVM. We can take any ratio through this slider. I'm taking 80% and 20%, and when I click proceed, it will show me this other video where I can click on this split data and it will split in 80% and 20% of the data. I can give these parameters, enter L, enter C, and I'm now clicking train classifier. It will train, started training, finishing training. Then I will test classifier, started testing with CPU, started testing with CPU. Now started testing on thread, which is executing multi-threading. It is finished testing on thread, and now I will click on the show results. Now, as you can see, these are results for algorithms, SVM, training data size, testing data size, training time on CPU, single-threaded application, threading time, multi-threaded application, testing time, and this is backend time, train plus test. Backend time is more than single and multi because network cost is also there. Then backend test. We can see that all of the algorithm has good accuracy. Now I'll go back and I will choose, I'll keep the data distribution same, and I will click proceed. I'll split the data. I'll set K to 3. Now train classifier, it has started training, finishing training. Test classifier, started testing, finishing testing, started testing on thread, finishing testing on thread. Show results. Now we can see that these are the result. It is in the same format that was for SVM. I'll go back. This I'll set for LR, keeping the training and testing distribution same. Proceed. Split data. I'll take R as 5 and iterations as 50. Train classifier, finishing training, test classifier, show results. These are my results with the same format. As you can see, it has good accuracy for 98%. And here also the backend time is more than the multi-threaded and single-threaded because of the network cost we assume. Now I'll go back and test my last algorithm, decision tree. Keeping the data distribution same, I'll click proceed. Split data, minimum instances 5, seed 1, and maximum length, let's keep it to 6. Train classifier, test classifier. Show results. Now you can see it has very good accuracy in comparison to other two algorithms with very low time for testing in single-threaded and multi-threading, and also backend time is little more, but it also has the training cost and network cost. So with that, it was our 80% demo. Remaining work is to more modify the UI and also um, um, include logging feature in this application. Thank you. Hello, this is the GPU part of our project. I am demonstrating here task 8, implement GPU based learning algorithm. Task 19, performance analysis of GPU implementation. And task 20, execution time analysis of GPU implementation. So this is the UI. I can give the K value of my KNN algorithm. Let it be 3. And this slider is to change the training and testing ratio. I can set it to anything. Let me set it 80% of training and 20% of testing. When I will click the proceed button, it will train the training data set and test on the testing data set and give me the performance analysis result as well as the execution time. So these are my performance analysis parameters: TAR, true acceptance rate, false acceptance rate, true reject rate, and false reject rate. I'm also showing training time and testing time. I can change to 61 training and 39 testing. I'll click again, and now the parameters are changed. So depending on training and testing ratio, I can also change K value, and here it is for 5, for 9, thank you.